All right, so today we're starting chapter 8. Chapter 8 deals with inequality and the modulus function. All right, here are some theorems of inequality. Largely, they're sort of like largely intuitive by now. Having gone through, let us say, CSEC math and maybe add math, by now some of these things should be intuitive. But we can go through them. When I say intuitive, maybe we would not have written them down in a theorem or as a theorem, but it's something that we understand. So if, for example, all right, so theorem 1 says, if A is greater than B, then A plus C is greater than B plus C. So all that is simply saying is that if, for example, you have what, 4 is greater than 3, then 4 plus 2 would be greater than, would be greater than 3 plus 2. That's what it is saying, which is 6 is greater than 5. So all that this is saying, theorem 1 is saying, if A is greater than B, then A plus C is greater than B plus C. In other words, you can add the same number to both sides of an inequality and the inequality will not change. All right. Now, theorem 2 says, if A is greater than B and C is greater than 0, that simply means that if C is positive, then AC would be greater than BC. So all that theorem 2 is saying, if you multiply both sides of an inequality by a positive number, the inequality would not change. When I say the inequality would not change, I'm meaning that what I mean is that if it is a greater than inequality, it would remain a greater than inequality. Theorem 3, if A is greater than B and C is less than 0, now C is less than 0 means that C is negative, then AC would be less than BC. So what we're seeing in theorem 3 is that if you multiply both sides of an inequality, by a negative number, the inequality sign will change. The initial sign was a greater than sign, and after you multiply both sides by a negative number, it changes to a less than sign. So theorem 3 is saying, if you multiply both sides of an inequality by a negative number, the inequality sign will change. Theorem 4, if A is greater than B, then 1 over A is less than 1 over B. And this is it should be largely intuitive. All that this is saying, like 4 is greater than 3, then a quarter must be less than a third. That's what it is saying. All right. Now, with that in mind, with the theorems in mind, theorem 1, which says if you add the same number to both sides of an inequality, the inequality will remain the same. It wouldn't change. If you multiply both sides of an inequality by a positive number, the inequality will not change. The sign will remain the same. Theorem 3, if you multiply both sides of an inequality by a negative number, the inequality sign will change. And theorem 4, essentially saying that if A is greater than B, in other words, if you invert both sides of an inequality, you must change the inequality sign. If you invert both sides of an inequality, I'm guessing this is important, you must change the inequality sign. All right. All right. Example 1. Example 1 is asking us to find the range of values of x for which x squared minus 3x plus 2 is less than 0. All right, to answer this question, we're going to draw a sketch of the graph of y is equal to x squared minus 3x plus 2. In particular, we only need the x-intercepts. We only need the x-intercepts. Now, the x-intercepts are the values of x for which x squared minus 3x plus 2 is equal to 0. All right, so solving, I'm going to factorize. I have x here, 2 and 1. I think both needs to be negative, is equal to 0. So here I'm multiplying two things and I'm getting 0. So it's either the first is equal to 0 or the second is equal to 0. Therefore, x is equal to 1 or x is equal to 2. So x is equal to 1 or x is equal to 2 are the roots of x squared minus 3x plus 2. Now, if you draw a graph of y is equal, if you draw the graph of y is equal to x squared minus 3x plus 2, x is equal to 1 and x is equal to 2 would be the y-intercepts. So I'm just going to do a sketch. This is a positive x squared graph, so it's a parabola. It's a smile parabola. This is my x-axis. And the x-intercepts are 1 and 2. Those are my x-intercepts. All right, so let us say the y-axis is over here somewhere. This is the y-axis, and this is the x-axis. Now, the x-axis is the line y is equal to 0. And this is a sketch of y is equal to x squared minus 3x plus 2. Everywhere on that graph, y is equal to x squared minus 3x plus 2. Everywhere on that graph. Now, so the values of y above the x-axis is where y is positive or where y is what? Greater than 0. And below the x-axis is where y is less than 0. What we want are the values of x for which the graph is what? For which x squared minus 3x plus 2 is less than 0. Now, what you'll notice here, using the intercepts sort of like as a, let me change the color here, as a sort of like a dividing point. I can sort of divide up my graph into, let us say, 6 regions like this. All right. So these are 6 regions, or let us say 3 regions. 1, 2, 3. 3 regions. Now, in this region of the graph, this is where what? X is less than 1, but y is greater than 0. In this region of the graph is where x is what? Less than 1, but y is greater than 0. Over here is where x is greater than 2 and y is greater than 0. We know that y is greater than 0 because in that region of the graph is above the y-axis where y is greater than 0. in this region of the graph, x is less than 2, greater than 1, and y is less than 0. So in region 1, where x is less than 1, y is greater than 0. In region 3, where what? X is greater than 2, y is greater than 0. In region 2, where x is less than 2, but greater than 1, y is less than 0. So the solution that I'm looking for are the values of x in region 2, where y, which is x squared minus 3x plus 2, is less than 0. So the solution of x squared minus 3x plus 2 is less than 0. The solution our solutions are x is less than 2 but greater than 1 are the values of x for which x squared minus 3x plus 2 is less than 0. All right, let's see example 2. All right, let's have a look at example 2. All right, so example 2 again. Find the range of values of x for which 2x squared is less than 3x plus 2. Now, what I would do is I would make one side of this inequality 0. So it would be 2x squared minus 3x minus 2 is less than 0. So the next thing I would do to solve this is I would use a graphical approach. To use the graphical approach, I need to draw the graph of y is equal to 2x squared minus 3x minus 2. To draw that graph, I would need to know the roots of 2x squared minus 3x minus 2. And the roots would be the values of x for which 2x squared minus 3x minus 2 is equal to 0. So I'm going to solve the equation 2x squared minus 3x minus 2 is equal to 0. Factorizing, we have 2x, we have x, we have 2, we have 1, this is negative, and here is positive, and this is equal to 0. So now 2x plus 1 is equal to 0, or x minus 2 is equal to 0. So x is equal to minus a half, or x is equal to 2. So those are my my intercept. Those are the roots. And if I draw a graph of the graph of y is equal to 2x minus 3x minus 2, x is equal to minus a half, and x is equal to 2 would be the roots. So if I draw a sketch, it's a positive x squared graph, so it's a smile. So this is my x-axis, which is the line y is equal to 0. This is x is equal to 2. This is x is equal to minus a half. And my y-axis would probably be somewhere around here. All right. So this is my y-axis. What I want is the region of the graph, the values of x, or the values of x in the region of the graph where 2x squared minus 3x minus 2 is less than 0. All right. Let's change the color here a little. And if we do what we did in the last for the last question, divide up the graph according to the roots. We basically have three regions. This is where x is greater than 2 and y is greater than 0. This is where x is less than minus a half and y is greater than 0. And here is where x is less than 2, greater than minus a half, and y is less than 0. So the values of the x where the values of x for the region of the graph where y is less than 2, where y is less than 0, the solution of 2x squared is less than 3x plus 2, which is the same as saying 2x squared minus 3x minus 2 is less than 0. The solution is x is less than 2, but greater than 0, greater than minus a half are the values of x for which 2x squared minus 2x squared minus 3x minus 2 is less than 0. All right, so this is the graph of y is equal to 2x squared minus 3x minus 2, and y is less than 0 in the region of the graph where x is less than 2 but greater than minus a half.